Data preparation is the most important step in machine learning. How well you prepare the data will define the ability of your model to learn. You prepare a nice and crisp data set, and the model will do a good job. But before you proceed to actually wrangling your data, it's important to answer a few questions. What is the right data format to be used in machine learning? What is the best order to be followed? What are the key operations that you need to know about right away? In this video, I'll help you answer these and other related questions. I'll give you some tips, some starting points, some snippets of code, and hopefully this will inspire you to explore these topics further on your own. My name is Alexander Korobov, and this is Machine Learning DIY. Machine learning is essentially a chain of data transformations, a pipeline. We start with raw data describing some events. We turn it into a table, observed features against observed outcomes. We clean messy parts of the data, perhaps replace missing values with some reasonable proxies. We format the data so that the learning algorithm can consume it. And finally, the learning algorithm transforms our data into an insight, a function capable of taking features and translating them into the most likely outcome. When we say data preparation, we loosely refer to the steps that happen before the learning algorithm. These steps, they don't necessarily need to be implemented by you. You can outsource them either to a third-party vendor system or to the learning algorithm itself. For example, if we are exploring the traffic on our website, we can outsource data preparation to Google Analytics. In this case, we don't need to worry too much about data preparation because the vendor has taken care of that. By the time we're done with data preparation, our data should be in a certain format. Let's define the most typical version of that format. For now, we'll be working with tabular data or data frames as opposed to, say, sounds or images. This simply means that we're dealing with a table where some columns correspond to features and some to the target variable. Features or explanatory variables can be either numeric or categorical. Think of the diamonds data set that we considered last time. It has both numeric and categorical features. Numeric features like depth, size have numeric values 0.23, 61.5, and 55. The categorical variables, on the other hand, have distinct categorical values like ideal, premium, good, and fair. By the way, the target variable can also be either numeric or categorical. Our input table can be characterized as tidy. This simply means that each feature has its own column, each observation has its own row, and each value has its own cell. The names of features are captured in the first row of the table. Our input table can be stored on a computer or a cloud as a CSV file. A CSV is simply a text file that uses commas to separate columns. By the way, you can have missing values in your data. In those cases, simply leave the cells blank. There's a plethora of tools out there in Python and other languages for manipulating data. All these tools, they are designed to make your life easier, and they have their own pros and cons. You can use a combination of tools for different parts of your data preparation pipeline. So feel free to experiment and explore. You can also use any tools that you're already familiar with. It could be Excel, deep learning in R, or a production level language like Java. But don't overdo it. In general, it's more important to understand what needs to be done as opposed to how it can be done. And finding the right tool for the job is usually much easier. And also, it's a lot of fun. It's like shopping for a new gadget when you can get most of the gadgets or packages or libraries for free. So feel free to play around with this, but most importantly, just get to the format that we described as fast as you can, and you can always revisit your choices later. In this video, we'll get familiar with how data can be manipulated in H2O, and in the future videos, we'll consider other tools like pandas, deep learning in R, etc. Let's spin up a Google Colab notebook and do some coding. Feel free to follow along. This time, let's create our own copy of the file and upload it to the Google Colab environment. To load our CSV file into an H2O data frame H, we use the command import_file. The command has a number of optional arguments and you can learn about those later. By the way, if you don't know or remember the name, the syntax, or the arguments of a certain command, you can always ask Google or ChatGPT. For example, let's ask ChatGPT how to import a file using Python H2O. This will not only tell us how to use the command, but will also provide us with some useful context, like importing the package, initiating the engine, and getting a glimpse of the data. Similarly, we can use Google to search for the relevant documentation. Let's use the same query, how to import a file using Python H2O. In this case, the first link will take us to the native H2O documentation of the command import_file. This is also an excellent source of information. Once we've loaded the CSV file into the notebook, we usually want to take a look at the summary of the dataset. We want to review the dimensions of the table, column names, their types, and basic summary statistics for each column. This can be done with the method describe. For now, let's just confirm that the target variable is numeric and our features are either numeric, denoted with int or real, or categorical, denoted with enum. Let's go through the 5 most common types of data manipulation. The most frequent operation that you'll need to use with the data frame is selecting columns. We can select columns by the column name, or we can select several columns using a list of column names. The second most typical data manipulation is about selecting rows. For example, let's select the 14th row from our table. Keep in mind that in Python the rows are counted from 0. We can also select a range of rows. For example, let's select rows indexed 13 to 27. One important variation of selecting rows is called filtering. This means that we're selecting rows based on a condition. For example, let's select rows whose price is greater than 10,000. The next most important type of data manipulation is sorting. This method of the data frame will arrange rows according to a given column or list of columns. For example, let's sort our dataset by the column price. We can also sort by 2 columns. For example, let's sort the rows by the column color, and within each color, we'll sort the rows by price. Another common operation is to create new columns. The new columns can be used as new features for training the model or can help us explore the data. Let's create the column new_feature, which is a product of the feature caret and depth multiplied by 2. Note that each time we apply a transformation, it shows as another H2O data frame. If we want to create a copy of that new data frame, we can do that by using the command deep_copy. Finally, we often need to calculate some summary statistics for a given column. For example, consider the column price. Let's calculate its average, sum, and minimum. There are hundreds of other data manipulations available in H2O. You can learn about the rest as the need arises. I'll leave a link to the comprehensive documentation on H2O data manipulation in the description. If you've read any typical blogs about data preparation, I bet you have spent most of the time reading about things like handling missing values, turning categorical variables into numbers, splitting data sets into training and validation parts. If you use H2O, learning about these particular steps is not a priority because H2O automates these types of data preparation. This is one of the reasons why H2O is an excellent choice for quick prototyping. We have gone very quickly through some of the key concepts in data preparation. We have also reviewed how the basic types of data manipulation can be performed in H2O. In the future videos, we'll make sure to revisit this and other related topics, and we'll deepen our understanding. I hope you've enjoyed the video, and I'll see you in the next one.